Hello and welcome in. Mark here, aka the Markster. This is video number 43 in the FreeCAD series. Today we're going to be making a dividing head. We'll switch over to my browser here. This is a video by Mr. Pete 222 in which someone made him a model of these dividing heads and printed them out and mailed them to him. And he has some videos on what these are used for, and I'll put a link to the description. A link in the description to this video if you want to watch it. Basically, what this is used for is in a machine shop. You have a device called a rotary table, and that rotary table is used to create hole patterns, and you can use it also for things like cutting gears. So the rotary table is a device sort of like a record player, where instead of a record on top you have your workpiece, and let's say you want to drill this 3-hole pattern here, and your workpiece, you would mount it on the top of your rotary table, and you have a little handle on the side. When you turn the handle, the table spins. So you could mount this on, for example, a drill press, and drill the first hole, turn the handle a little bit, drill the second hole, and turn a little more and drill the third hole. So turning that handle obviously is a critical part, stopping exactly at the right spot. So that's where these little holes come in. You have a little peg that'll go into these little holes and tells you exactly where to stop. So each of these hole patterns, like for example, if you had one with 25 holes in it, you could make a 5-hole pattern by skipping and only stopping at every 5th hole. It's a little more complicated than that. Typically the handle turns not a 1-to-1 ratio, and he'll explain all that in the videos. But that's the gist of what we're going to be making today, is one of these, this one right here, or something similar to it. So if you're coming to FreeCAD for the first time and you've never used it, you'll be able to use this model to make one of those dividing heads, because the way I'm going to design it is going to be parametric, and you'll be able to come in and just change a few properties. For example, how thick do you want yours to be, what's the diameter, and etc. So this is probably going to be kind of a long video. The first thing I'm going to do is start defining a few of these variables. So I'm going to go to this dynamic data workbench, and I'm going to create a DD object. This is a container for dynamic properties. We'll add a property to it, and this will be a length type property, and this is going to be our disk diameter, and I'll leave it at 0. And then come in here and change to what I want. So let's just make this one 8 inches. What do you say? 8 times 25.4. So I'm saying 8 times 25.4 because I'm set up in millimeters in FreeCAD. So even though we're going to be working in inches, I'm going to leave it in millimeters and just create the little formula here. They're 25.4 millimeters per inch. So we can see the millimeter amount and we can also see that it's 8 inches. So that's our disc diameter. The next thing we need to know is how thick that disc is going to be, which is another length property. We'll call this one disc thickness. And I'm going to set that to, let's say, 1/4 inch. So we've got our disc diameter and our disc thickness. Now there's a big hole in the middle. Let's go back here and look where it fits over the shaft. So I'm going to call that the shaft diameter. That's another length type property. Let's just call that shaft diameter. And this will be, let's just use 1 inch for that. Now we're going to go to part design. We can do this in different workbenches, but since I've been teaching part design here lately, we'll do it in part design. So I'm going to create a new sketch, which also creates a new body. We'll put it on the XY plane, and we'll draw some circles in it. The first circle is going to be the outer diameter, and we'll constrain that diameter. dd.dd, this diameter. Alright, and we need another hole for the shaft, a circle for the shaft, and this is going to be the shaft diameter. So that's the disc. And we're going to pad that to the disc thickness. So that's the basic outline of that disc. Your shaft diameter will probably be different, and you don't make any change to the sketch. Don't fool with that. Just make your change here. If you want a different shaft diameter, let's say you want 1.5 inches. Let's put a parenthesis in here. 1 + 1/2, like that. And now watch this hole when I refresh here. So this is parametric. Now we need also these mounting holes. Let's go back to these holes here. These holes are mounted to the rotary table. And we need to know how big those holes are, the radius. We need to know how many of them. Is it a 3-hole pattern or 4-hole pattern? And we need to know how far from the center will be the center of those holes. So I'm going to call this the mounting holes, and the first one will be mounting hole diameter. That's the diameter of each mounting hole. Let's add another one. This is going to be a radius. We'll call this mounting ring radius. This is going to be the distance from the center to the center of one of those holes. and we need to know how many holes to make. So this is going to be an integer type property, and this will be mounting hole pattern, which is going to be 3, but it could be 4. You could change it here. So mounting hole diameter, I'm going to make these what seems reasonable, 3/8 inch. And the ring radius, I'm going to put that at 2 inches. We'll see what it looks like, and we'll adjust it to make it kind of look close to what we need. So let's go ahead now, and we're not going to counterbore them just yet. We're going to go ahead and make these holes first. So we'll use a subtractive cylinder for that. So the red denotes where that cylinder is at currently, and we're going to attach that to the XY plane. See that? And we're going to move it in the X direction by, what do we call this? The mounting ring radius. It looks like 2 inches, a little bit too far, so we'll need to adjust that. I don't have Mr. Pete's actual numbers that he used. And I don't have access to the expression engine. Notice we don't have the little round blue icon here. So I'm just going to accept these defaults and then change it in the properties. Click on it here in the tree. And we're going to choose the radius here. And what did we call that? Mounting hole diameter divided by 2, since that's a diameter and this is a radius entry here. We don't have diameter as an option here yet. We don't need it. And the height of that cylinder, the subtractive cylinder, is going to be the same as the disc thickness. Hopefully we can get away with that. If we have to, we can make it a little bit taller. It doesn't matter if it sticks out a little bit. But it looks like that's working fine. And I do need to adjust that mounting ring radius. Is a little bit too much, I think, for this particular size. So let's make that 1 + 1/2 and see what that looks like. And watch when I refresh. Is that a little bit better? Not quite there yet. One and a quarter maybe. Refresh that. Yeah, that looks good. So now let's go ahead and create the whole pattern for this. Just select the cylinder and choose this, create a polar pattern feature. And this is going to be 3. But we want to reference this property and not just put 3 in here. That way, if we decide to change it later, if you need a 4-hole pattern on yours, you'll be able to come here and just change this to 4. So watch when I change that to 4. Now I have a 4-hole pattern. So we're going to put that at 3. So now we need to counterbore these. Now you might elect not to and just drill these and counterbore them yourself. Just put you some real small holes here as a pilot hole. But we are going to go ahead and counterbore them while we're at it. So what do we need to know about the counterbore? What are our variables that we're going to need for that? Well, how big is the radius of the counterbore? That's one thing we'll need to know. And that'll be a length property. And I'm going to call that counterbore diameter. So the counterbore diameter, in this particular case, we're using 3/8 inch holes. So I'm going to make this 5/8 inch. Of course, it'll depend on what you need for yours. And how far down does the counterbore go? Does it go like halfway down? That seems reasonable. So we'll have another property, and I'm going to call that one counterbore depth. And that'll be this thickness. I'm going to divide that by 3. So we'll go 1/3 of the way down. That's how I'm going to do this. Alright, and now we're ready to make that. And that's going to be a subtractive comb. And we're going to attach that comb to the circle here. And then we'll set the Z direction down. Notice it's right even with the top of here. So we're going to move it down in the Z direction by the amount of, what do we call that? Counterbore depth. And that's going to be a minus value, so let's multiply by -1. Up would pick it up higher, so we need to go negative to go down some. And we'll set the radius in the other property, since we can't get to that expression engine from here. So I'll select the cone here, and radius 2 is the top of the cone. Remember, the cone was, let's double click on it, it's bigger at the top. So radius 2 is that bigger radius, and that's going to be the counterbore. Where we're at here, counterbore diameter divided by 2, since this is a radius field. And the height, well, let's set this other radius. This is going to be equal to the mounting hole diameter divided by 2. And the height is going to be this thickness minus how far down we moved it, which was the counterbore depth, right? Counterbore depth. So that should give us our our counter bore. If you wanted to go a little deeper or a little wider, this can be changed very easily. Counter bore depth. If you want to go halfway down instead of a third of the way down, you could divide by 2 here. Or you could specify exactly how far to go. So that looks pretty good. And now we need to make a polar pattern of this subtractive comb, and that'll be the same way we did a moment ago. And this will be also the mounting hole pattern. There we are. So we've got our dividing head plate coming along quite nicely. And it's nice and parametric. So we can change any of these properties and get it exactly like we want. So if we wanted just 6 inches instead, very easily, come in here and change it to 6 inches. And then when we refresh, now we have a 6 inch 6-inch dividing head plate. Now we're ready to begin adding our hole patterns around here. So let me go ahead and make this a little bit bigger. Back to where it was. We'll make an 8-inch wheel here. Now the radius here, I'm going to call this a ring radius. Let's go ahead and make one, make our first one. It doesn't really matter on these, but you can put it where you want it. So we're going to need a ring radius value, how far to start that hole, how big will those holes be, and we need to know how many holes in that first ring pattern. And we'll put, I don't know how many yet. Let's see how many he had on his. 1, 2, 3, 4, 5, 6. Let's see if we can put 6 on here. Let's begin with the first one. So let's select our DD object and add another property. And the first one is going to be, I'm going to call this ring 1 radius. This will be the first ring. And let's add another property. And this will be, we're going to call this small hole diameter. Small hole diameter, and readjust these here to give us a little more room down here. That's going to be how big those small holes are, and I'm going to make that 1/8 of an inch. And this first ring radius is going to be, let's start that at 2 inches. We'll see what that looks like. And we need to know how many holes, what's this hole pattern going to be for ring 1. So ring 1 hole pattern is what we'll call that. And that'll be an integer value. So ring 1 hole pattern. have here? I don't remember. This finger's in the way. We'll just make it 18. We'll start with 18. And I can just roll my mouse wheel forward and get to 18. Alright, let's go ahead and set up that whole pattern. We need to drill a hole first, don't we? So that'll be with another subtractive cylinder. And we will put it on the XY plane. And we'll move it in the X direction. How far? I don't remember what I called this. Ring 1 radius, wasn't it? Okay. So that'll be where it's at. Looks about right. It's going to need to be a little smaller. And we'll set that in a moment here. Click on the cylinder. And we'll set that radius to small hole radius. Small hole diameter divided by 2. Alright. That looks okay. Let me reference that video again. Looks about right. And now we need to polar array this subtractive cylinder. And that's going to be ring 1 whole pattern. Alright. So that's our first hole pattern, our first ring pattern. And now the second one. Add another cylinder. Attach it to the XY plane again. And we need to move it. We don't know where to move it yet. We don't have a I'm trying to think, should we just make a variable and so it'll be bigger than the one before? And the variable will be how much bigger will the second ring be compared to the first. I think that's going to be the way to do this. So we'll say okay for that, just for now. And we need to add our properties. So I'm kind of making this up as I go along here. So this is going to be, let's call this ring separation. So this is the radial distance from one ring to the next. And our holes are 1/8 inch. So we can make this, let's try 1/4 inch. I'm just going to leave it at 0 here. And let's set that up at 1/4 inch. We can come back and change this if it doesn't look right on the screen. Alright, now one more property that we're going to need is the ring 2 hole pattern. So let's add that. And that'll be another integer value. Ring 2 hole pattern. Try to give these nice descriptive names. And I'll make that one 19. But it does not have to be one more than the other, than the one before. It could be some other value. Alright, and now let's see. We didn't move that one out yet. We didn't know how far to move it yet. So this is going to be ring 1 radius plus ring separation. And say OK. And of course that's way too big. We'll set this radius to, what do we call that, small hole diameter divided by 2. Yeah, that seems about right, doesn't it? The same separation. We might be a little bit more, but I think that's going to be okay. Now let's go ahead and make that polar array here. Ring 2 hole pattern. Alright. And that one has 19 in it. And let's make another one. Well, first let's create our variable here. Click on the DD object. And this will be ring 3 hole pattern. And that was going to have 20. And now add another subtractive cylinder for that third ring. And we're going to map it to this XY plane again. And we'll move it in the X direction by ring 1 radius plus what do we call that? Ring separation times 2, right? Because this is the third ring. And we'll set that radius here in the properties. And it's that small hole. What do we call that? Small hole something or other. Small hole diameter. There it is. And the height is this thickness. We didn't set the height on that one. Go ahead and set that. I thought about it when I set that height. And cylinder, this one we didn't either. So that could be a bad thing if we change this thickness. The holes won't go all the way through if it's too thick. So now we've got that set. And I made a mistake there, didn't I? This is a radius property, not a diameter. So we need to divide that by 2. It's okay, we all make mistakes, and I am forgiving of my own mistakes. So this will have 20 in ring 3. So we'll make another polar pattern feature. And this will be ring 3 hole pattern. There it is. Give it a moment. We're coming right along. We need 3 more rings. Let's select our DD object. There'll be another integer. And it's going to be ring 4 hole pattern. It's important to give these long descriptive names because you can see how many we have here. Now we could have created separate groups. Instead of all in one default group, we could have mounting hole group, ring 1 group, and so on. So this is going to be, there it is, ring 4 hole pattern 21. So let's add another subtractive cylinder. Attach to the XY plane and move in the X direction. Ring 1 radius plus ring hole separation, ring separation, what do we call that? Ring separation times 3 here, isn't it? Let's see where that puts it. Yeah, times 3 for ring 4. And we'll say OK. And that hole is way too big, but that's okay, we'll fix it. Small hole diameter divided by 2. Refresh. Alright, and don't forget to do the height here. This thickness. And now we're ready to add another polar pattern feature. And the number here is a ring 4 hole pattern. Did I not make a ring 4 hole pattern variable yet? Let me just call it 21 for now. Your ring 4 hole pattern. Why did I not see that? There it is. Ring 4 hole pattern. Alright. Clear these arrows out in case we get another. It'll catch our attention. So this is looking a lot like that one, isn't it? You see how these patterns are all lined up here, and then change a lot. These are doing the same sort of thing here. So we've got 4 hole patterns, and we need 6 we're going to make for this. And you see how I'm doing it. So if you wanted to add more, it's not that difficult. Now this dynamic data, the tool here, it has to be installed separately to FreeCAD. So if you install FreeCAD and download it and install it, you go to the Tools menu here, look for Add-on Manager, and you'll be in the Workbenches tab, and just look for Dynamic Data. They're alphabetical. Click on it and click Install. So that's how you would install this add-on. And let's see what we need. We need a ring 5 hole pattern variable. So we select our DD object, the plus icon. This is another integer. This is ring 5 hole pattern. It's going to be 22. I better save this file right now. Should have saved it earlier already. Put it in YouTube with the other files. This is going to be 043 underscore dividing head plate. Because if FreeCAD crashes and I lose all this work, I'm not going to be a happy camper. Alright, so we've got DD ring 5 hole pattern. Let's go ahead and make the 6 hole pattern as well. And this will be ring 6 hole pattern. This one's going to have 23. And of course you can adjust these. It's going to take a little while to refresh this these part design arrays are not optimized for efficiency. So let's add another subtractive cylinder, map it to the XY plane, and move it. Ring, what do we call this? Ring 1 radius plus ring hole separation times 4. Okay, and now that hole's too big, and it's a small hole diameter divided by 2. Alright, and the height. Let's not forget the height. Now let's go ahead and make this pattern. This is ring 5 hole pattern. Give it a moment. Here we are. And now what's the next step? Alright. This one will be at ring radius. Where's that at? Ring 1. Ring 1 radius. There we are. Plus that separation times 5, because this is ring 6, and we'll say OK, and that hole's too big, and that's going to be the small hole diameter, about 2. Almost finished. Let's refresh that. Yep, looking good there. And now another polar pattern feature. I forgot the height. We'll have to go back and add that. And this is ring 6 hole pattern. And let it make a preview for us. Alright. So that's it. We could, the advantage of using that ring separation now is it's much easier if we want to make a little more separation, since we have room. And like I said, it doesn't really matter the radius of these, as long as your little peg holder thing can reach it. So we can move our separation. Where's that ring separation? Instead of a 1/4 inch, we can make it 5/16. And let's see what happens when we do that. I'm gonna refresh. It'll take a little while. But watch these holes. Keep your eye on the prize. You gotta be patient with FreeCAD. Sometimes you think it crashed, but it didn't. It's just taking its time. So when you make these adjustments to your DD properties, be patient. I had a visitor, so I had to pause. So this is our parametric dividing head plate, and you can see how to modify it. And yet another visitor. So where was I at? We see how to modify these properties. Now if you don't want a particular ring, so you don't want ring 6. I haven't tried this yet. This is live TV. You can set this to 0, I believe. And let's see if ring 6 disappears, or if it gives us an error of some sort. Yep. It does not allow a 0 hole pattern. So I guess you're just going to be stuck with that. Now if it goes, another error you might end up with is if it goes beyond the edge, that's going to be another error because of this workbench that we use part design. Had we done this in another workbench, you would not have that problem to contend with. So you're going to have to make 6 rings unless you come in here and delete these. You start at the bottom. I don't want to delete it. Let me save this file. But I will. I'll delete it just to show you. So this is ring 6. If we delete it, it disappears, and then we can delete this cylinder 6. So that's how you can just have 5 holes. Now I'm going to use the undo feature to undo that delete and undo again to put it back in there, and then refresh. And I'll make this visible again. Now, if you want to add more rings, you saw how I did it. Just do it the same way. You add another cylinder, move it. You saw all that several times. If you want to print this on your 3D printer, what you need to do is select the body object. Don't select this last pattern. Select the body. Go to the File menu. Choose Export. And you can choose the STL format. Most slicers will have that. And I'll include that also. But yours is going to be different, no doubt. I mean, these are not going to be the right dimensions. But let me just put it in my documents folder. So I'm going to have, call it dividing head. And now when I pull up this, it shows up here. And I'll just double click it. And I'm going to choose Cura. Let's always open STL with Cura. Oh, that's Windows for you, isn't it? Let me just get Cura running. Hang on a second. So I've got Cura, Ultimaker Cura 4.5. Another common slicer is called Slicer, which I don't have installed. I'm just using Cura. So we open up Cura. Eventually it'll finish loading. Alright, and then we'll open the file. And I put it in my documents. And that is sorted by date, so dividing head STL. Ooh, boy, it's almost too big for my printer. I've got a CR10 Mini. Almost too big for mine. This is an 8-inch wheel. And then you would slice it, of course. I'm not going to teach you how to use your slicer because I'm sure you've used it many times. And this particular wheel would take 14 hours to print on my device. And here's a preview of each layer as it's printed. I'm using standard quality and I have a 0.4 millimeter nozzle on my printer. So anyway, that's how you would export your STL file, your model, into STL format. Sometimes I use AMF format, sometimes Wavefront OBJ. All three of those work well with Cura. Well, that's going to be it for today. I'm going to include a link in the description to where you can go to download this file. I'll put it on GitHub, on my GitHub repository, and I'll have a link set up in the description where you'll be able to go download this file and just make your changes that you need. You don't need to install dynamic data just to use the file. You only need to install this workbench if you plan on adding more properties or whatever to your DD object. So it's designed to be able to run even if you don't have the workbench installed. You'll be able to use the models that were created using the workbench. So that's going to be it for today. I thank you for watching. It was been kind of a long video, almost an hour. And have a great day.